All right, guys, what is up? Welcome to another episode of Black Hat Python. We have finished the decoder script here to decode the IPv4 headers. So if you remember from the previous, we created this IP class here, and we defined the struct for the IP header. Now, I'm not going to spend too much time on this because that was what the entire video was about. So basically, we broke it down into all these different variables here. These are the different sections of the IPv4 header. And with that firmly established, everything below this line is what I have added since then. So let's see what's going on here. We have basically made the IP addresses human readable. Because remember, if you remember from, I think, 2 episodes ago, all we had was a bunch of hexadecimal. So what we're going to do is we're going to put these IP addresses in a very human readable format. And we've imported IP address module here. We can use some functions from that to do so, right? We can take the source address, the destination address, and assign them to variables we can use then later. Now, also, we want to map the protocol constants to their names. So in the IPv4 headers, there are numbers that correspond to the protocols. Now, we want this to be very human readable for us, again, right? That's one of the big purposes of the decoder, right? To decode it into human readable format. So whenever we see 1, that corresponds to ICMP. So we're going to create a mapping, or I guess in Python we call it a dictionary, to map these values to the human readable version, right? So ICMP is represented by the number 1 in the IPv4 header, 6 maps to TCP, and 17 maps to UDP. Now this is just understanding the underlying protocol, right? Understanding what these headers look like, what the values are. But the Black Hat Python book saves us some time. It just gives us this information. So now we're going to, go ahead and create the self.protocol variable, and that's just going to store this info here, right? And then if it finds any other number than the 3 we defined here, it's going to throw this error here. So we got some error handling built in. It'll say that there's no protocol for, and it'll tell you what number that is so you can add it to your mapping if you need to. And then down here is the actual sniff function that we have written. So this is a completely different function from, separate from this class here. And basically the first thing it's going to do is check if it is Windows or Linux, right? So if it is Windows, then we're going to need to use IP proto IP as opposed to IP proto ICMP. And then we're just going to set up our sniffer first. So this line here is basically just creating a raw socket and binding it to the public interface, right? Like these 2 lines are doing that, right? And then after that, this line here is all it's telling it to do is include the IP headers, right? Because without this, we wouldn't have the IP header information. So we definitely want to have that as well. So that's why we have this line here. Now, once again, it's going to check after that's complete if it's a Windows system. Because if it is, we're going to need to enable promiscuous mode. On Linux, you have that by default, I do believe, so you don't need to do this. But yeah, and this is why it's showing red here, because this IOCTL is like a Windows thing, I do believe. And so the code will run on Linux even though it's red here. But something to keep in mind, this is like if it's Windows, enable promiscuous mode. And now we're going to have a little bit of error handling here as well. And this try and a while loop inside the try here. Because, yeah, this is like one of the big meat and potatoes of the program as well. And so basically inside this loop, right, we're going to continually read in packets and parse the information that's coming in, right? So we read the packet and we pass the first 20 bytes into this variable here, IP header, and then we can initialize the IP structure and print out the information that we actually captured. That's what we're doing down here, right? So basically, when we run this, it's going to continuously listen, right? This is a sniffer here. So it's going to continuously listen for packets. And say if I go to a web page, it will grab the IP header and parse through it, and it'll print out protocol, then the protocol that I'm using, so ICMP, TCP, or UDP, and then it will print the source address, so my IP address, and then the destination address, so the address of the website or whatever I make a request to, right? So that is what that's going to look like. And then the exception here is if there's a keyboard interrupt from the user, right? If it's Windows, we want to turn off promiscuous mode, because remember up here we enabled promiscuous mode, so then we want to, do the maintenance, tidy up of turning it off afterwards. And regardless if it's Windows or Linux, if you do a keyboard interrupt, it should exit the program, right? So that's all that's going on there. And now if you run this as the main, if you run this file directly, basically, what it's going to do is it's going to look for your arguments. If you have an argument, then it'll set that as the host. And remember that host is passed in here to this function. So you can specify a different IP address, basically. Otherwise, it's going to default to this one, this IP address right here. So a little bit of, portability baked in. You can run this on different systems. You just pass in your IP address. If not, it'll default to this. So that's what is going on there. Now let's take a look at the actual demoing of this. I'll do this on my Windows box, just a little bit easier that way. So I will run this, and on my Windows box, I have it named what they had it named in the Black Hat Python book, which is sniffer IP header decode.py. So I'm going to run that, and now if I go to any website, let me refresh the page that I have here, and I might need to make a new request perhaps in order to actually grab it. So it should be picking up the actual code here. It is listening, but let's see, all the tabs I have are currently things that I'm using. So I need to find, there we go. Took a minute to find something that wasn't cached, because I have a lot of tabs open, but I think they're saving a lot in the browser cache. But yeah, here we go. You see that it actually grab this data from the IPv4 headers. Now, Windows is very noisy. That's why you see a lot of stuff here. But yeah, if you recall, this corresponds to what we had, right? Protocol in the colon, and then which protocol? TCP in this case, right? Simple web request. I'm going to use TCP a lot of times. And it looks like we got, it also grabbed something with the number 2, which we didn't build in a mapping for, right? So it found something in the IP header, protocol map number 2, but we didn't have that defined. So error handling grabbed that, right? And yeah, this is basically how it's working. This is my IP address here, and that is the destination IP address. So yeah, pretty simple. We will be expanding on this next by building in ICMP, decoding the ICMP protocol. That's something we haven't dealt with yet. So that is the next step for us. So yeah, hopefully you guys are enjoying this and it's helping you so far. If it is, definitely let me know in the comment section below. Right now I'm in the process of learning Rust. I think Rust is a super cool, super handy language. I have a pretty decent grasp over Python, which is a pretty high level language. I want to supplement with also having a solid understanding of a lower level language. So I could go with C or C++, but honestly, I feel like Rust is the future of the low-level languages, and it's really doing amazing things, and it's a really cool language. So what I'm in the process of doing kind of on the side on my own time is taking these tools that we're building in Python and porting them over to Rust, creating the Rust equivalent to it. So, I mean, I could even show you guys a little bit of Rust if there's interest on this channel. Eventually, I'm going to use Rust to build my own custom hacking tools and things like that, and build all kinds of programs. Really, I might even play around with some embedded systems programming as well. Maybe program some microcontrollers, things like that. But yeah, let me know if any kind of Rust content might be of interest to you guys, and I could definitely make some videos on that. I am pretty early on in my learning there, but I love to learn, supplement my learning by teaching you guys things as well. I'm certainly learning a lot in this series, and I hope you guys are as well. So if you are interested in learning even more, and maybe you need to catch up on the series, you didn't see the previous videos, you don't have to watch them in any particular order, but go ahead and check out the videos on screen now, the Black Hat Python series. I'll see you guys right over in those videos. Thanks for watching.